All right, so we have two learning targets for today. So the first one here was to see how we could combine functions to create new functions. We want to do that using addition, subtraction, multiplication, and division. I'm going to call this learning target number 1, combining functions. All right, so the way it works is that you can add, subtract, multiply, or divide functions with the operation and we can simplify down our answer. So that's just what we saw in the pi activity. We subtracted functions. So in part 3, we did the revenue function minus the expense function. And we saw how we could simplify it down a little. We got rid of the parentheses. We combined like terms. So we just did it for subtraction, but it also works for the others. You can add, you can multiply, you can even divide. Now, another little note I want to make here is that if we ever multiply or divide by a constant. So a constant would just be like a regular number that does not have a variable attached to it, like 2 or 4 or 5. Those are constants. We're always going to make sure that we use parentheses around our function. So if we have some big function and we wanted to multiply the whole thing by 2, put the function in the parentheses, and that 2 is going to distribute to all of the parts inside the parentheses. That's what that helps us to see, is using that distributive property. All right, second learning target here is to evaluate combinations of functions for given input values. You're evaluating combinations of functions. Okay, so there's a couple of ways this can look, and it depends on how the information about the function is given to us. So if the function is given to us in the form of an equation, all we need to do is plug the inputs into the needed functions and simplify. So our example of doing this on the front side is taking a look at our revenue function. So if we say that R of n is equal to 19n, well, the input is the value for n. So it's the number that we're plugging in over here for the number of pi's in this case. And so if we wanted to evaluate R of 15, we just plugged 15 in place of the n. And we simplify it down, so we would just multiply them out to see what final result we get. So that's how we would do it from an equation. Another way that our function can be represented is as a table or a graph. So from tables or graphs, we are going to find corresponding outputs for the given inputs on the graph or table. Then we're going to use the outputs to complete the operation. All right, so let's take a look here at the first problem. So it's given us the graph of a function here, so we're going to call this f of x. And then it's also given us a table of values for a different function called h of x. And then we have also information about a third function that we're calling g of x. So g is in the form of an equation. We have h that's in the form of a table, and we have f over here that's in the form of a graph. So let's see how we can answer these combination questions, how we can find the information that we need to from a different kind of representation. So let's start here with part A. So we want to find h of 2, and we want to take that answer and add it to f of 2. So let's start with h. H is given to us here in our table. So just look at how this is labeled. This is the one with h. And the input is where the x values are listed. So the inputs are all of the x's. The output is what we have on the other side of our table. You can think of it as like the y value, the h of x value. Those are the outputs. So what we want to do here is we want to find the output when the input is 2. And so looking here in the input column, I'm just going to circle this piece. So when the input is 2, the output is -5. So I'm just going to use a little arrow here. We don't need to show any work or anything for that. We're just going to simply find it in the table, and we're just going to state what it is. So h of 2 is -5. Now we're going to go over here, and we're going to find f of 2. Well, because it's referencing f, we have to look over here at our graph. And the way that the inputs show on the graph, the inputs are going to be on the x-axis, and the outputs are shown here on the y-axis. So f of 2 really means what is the output when the input is 2. So it's kind of like going to the x value of 2, so we'll circle that right here. And all we're going to do is go up to our graph, and we're going to see where we hit the graph. So I'm going to make a little point there. And then we're going to go over here to the y-axis, which is where the outputs are, and we can see that the output value is 3. So in other words, when x is 2, our output is 3. Now that we found the individual output for each part, we are going to do the operation to combine them. So because there is a plus sign in between, I'm going to bring that plus sign down, and then we're just going to simply add it together. So -5 plus 3 equals -2. All right, let's take a look at the next one. So now we are doing g of 7, and we have a different operation, which is going to multiply by f of 7. So starting with g, we haven't used g yet, but remember they gave us information about g up here in the form of an equation. Well, the way it works in an equation is that the input goes over here on this right-hand side. The input is going to go wherever we see the variable. So in this case, where the x is positioned, that's the number that's going to go in. And the output is the result that we get. Over here on this side, the output is the g of x side. So if we're going to input 7 into this function, we're just going to plug 7 in where the x is positioned. So instead of writing x squared minus 4, we're going to write 7 squared minus 4. So that ends up being 49 minus 4, which just simplifies down to be 45. Okay, now f is going to bring us back over here to our graph. I want you to take a moment on your own and find f of 7. And when you have your answer, I just want you to write it down here below. Ultimately, these two things are going to be multiplied together. But let's see if you can practice finding f of 7. All right, so 7 is the input now. So we're going to find 7 where the inputs are, which is like on the x-axis. We're going to go up here to our graph. We're going to find our point. And notice how the output, we go all the way over here to the side, the output is 2. I'm just going to put a little arrow so I can put it next to that 45. F of 7 equals 2. And so then we're just going to multiply the two separate output pieces together. So 45 is going to multiply by 2, and that gives us 90. All right, now you'll notice the last one we have here. This is a representation of division because we have a numerator part being divided by a denominator part. So on the top, we have g of 5. So g is going to bring us back up here to our equation. This time, the input is 5. So the value that we're going to plug in for s right over there now is going to be a 5. So for the numerator part here, it's going to look like this, 5 squared minus 4. And that's really 25 minus 4, so that numerator ends up being 21. All right, we have one more with the x function, which is over here on our graph. I want you to practice this one more time here. Go ahead and find and write down what you get. What is f of 5? Well, it looks like it's going to be in the same place as f of 2. That's okay. So we get the same result there of 3. So when we then actually divide them, 21 divided by 3, we get a final answer of 7. All right, so one other piece of our check for understanding here that we're going to take a look at before we're done today, I'm going to skip down to number 3. So you'll notice here that they've given us new definitions now for f of x and g of x. Both of them are in the form of an equation. And when you have them both as equations, this is where we can think about combining the pieces together using any 4 of our operations. So here specifically, we're just going to look at subtraction and multiplication. But it would work the same way if you did it with addition or if you wanted to divide. So let's take a look at the first part together. So if we want to do f of x minus g of x, well, f of x is really just the same thing as 2x. So all we're going to do here is rewrite f of x with the equation part that represents f of x. So just the 2 of x part is going to go, sorry, not 2 of x, 2x is going to go here in front. And then we are subtracting here, so I'm going to do my subtraction sign. And we're subtracting g of x. Well, instead of writing g of x, we're going to write what it really represents, which is 3x squared plus x. But because we are subtracting here, we need to show that we're subtracting all parts of g of x, and so it has to go in parentheses. It's kind of like in the bakery problem, where we were subtracting the expenses. We had to put parentheses around all of the expenses to make sure that we are subtracting all of them. Now, all we need to do here to simplify this is to distribute that subtraction sign into our parentheses, so it'll look like this. And then we're just going to put like terms together. So I'm going to put the 2x together with the minus x. That makes positive 1x. And then I'll just keep the minus 3x squared behind it. All right, for the very last one here, we're going to do this with multiplication. So we're just going to copy f of x, and we're going to rewrite it as 2x. And that's going to be multiplied by the expression for g of x. And I'm going to use parentheses again to show that, since there's two separate pieces that are being multiplied. And what's a little different on this one, so notice how there's no subtraction sign in front. I'm not distributing a subtraction sign. Instead, we're actually going to distribute the 2x. So 2x is being multiplied by both pieces on the inside. And so that's going to make it 6x to the third plus 2x squared.